An LED strip is not one wire job, it's 5. And the reel in your hand decides which. This is how to wire LED strip lights the right way. On screen is the finished diagram, a supply, a controller, and an RGB strip broken out to its 4 pins. Single color or RGB, 12 volts or 24. Cut lines, connectors, and the one trick that saves a long run. Stay with me. Every wire explained. Then we build one live in the browser. So start with the strip itself. Before you wire anything, read the reel. First question, how many wires? A single color strip has just 2, a positive and a negative. That is it. One color, one brightness. An RGB strip has 4. One is the shared positive, the common anode, and the other 3 are red, green, and blue. The controller pulls each color to mix any shade you like. An RGBW or addressable strip has 5 or more. RGBW adds a dedicated white channel. Addressable strips add a data wire, so each little chip is driven on its own. Second question, what voltage? Almost every strip runs on low voltage DC, 12 volts or 24. It is printed right on the tape, and that number matters more than it looks. 24-volt strips lose less voltage over a long run than 12-volt ones. We'll come back to that. So 2 facts before anything else. How many wires? 2, 4, or 5? And what voltage? 12 or 24? Quick pause. The exact wiring diagram in this video is free to open in your browser at CircuitDiagramMaker.app. No install, no sign up. The link is in the description. Open it and follow along. Right, the power supply. Now the box that feeds it all, the power supply, sometimes called the driver. It converts mains down to your strip's voltage, 12 or 24 volts of clean DC. And you have to size it right. Sizing is simple arithmetic. Every strip lists its watts per meter. Multiply that by your total length, then add 20% of headroom. That is the supply you buy. Undersize it, and it runs hot, sags, and dies early. The 20% keeps it cool and calm. Then the controller. This is what actually sets the color or the brightness. For a single color strip, it is a simple dimmer on the DC side. For an RGB strip, it is an RGB controller, 1 positive in and the 4 pins out to the strip. The wiring order never changes. Supply feeds the controller. The controller feeds the strip, not the strip straight off the supply, if you ever want to dim it. Now the 2 things people get wrong with their hands, not their heads. First, cutting. A strip only cuts in certain places on the marked cut lines between the little copper pads. You will see a scissors icon and a line every few centimeters. Cut on that line, and every remaining section still works. Cut anywhere else, and you kill that whole segment. Second, joining. You have 2 ways to connect a strip. Solder the wires straight onto the copper pads, the strongest, most reliable joint. Or use a clip-on connector that bites onto the pads, faster and no iron needed. Either way, one rule rules them all. Keep the polarity, plus pad to the positive wire, minus to minus. On an RGB strip, line up all 4, plus red, green, blue, end to end. Get a pad backwards, and that section just stays dark. So match the little printed letters every single time. Now the mistake that makes a good strip look faulty. The far end goes dim and a little yellow. Feed a long strip from one end only, and the thin copper loses voltage along its length. By the far end, there's not enough left, so it fades and shifts color. That is not a bad strip. That is voltage drop. And here is the fix, power injection. Run a fresh positive and negative from the supply straight to the far end. Now, both ends get the full voltage, and the whole run is even. This is exactly why 24-volt strips are nicer on long runs. Less drop to start with. Wiring several strips? Run each one back to the supply in parallel. Not one long strip, daisy-chained off into the distance. And one more quickly. Stick strips into an aluminum channel. It pulls the heat away, and they last longer. One safety line. The strip side is gentle, low-voltage DC, but the supply's input is mains, and an undersized supply runs hot. So size it right and follow local codes. Now, let us see it live. in a browser. This is the free editor at CircuitDiagramMaker.app with a low-voltage LED circuit open. Follow it through. A supply on the left, a resistor to limit the current, then the LED with a clear plus and minus for polarity and a return to ground. Every wire here is a real electrical connection, not just a drawing. Select any part, and its properties appear on the right. Real labels, real values. And you can build one from scratch. Search the library, a supply, a switch, a light, a ground. Click to place each one. Then press W for the wire tool and click pin to pin. The wires route themselves at clean right angles. And here's the part one love. It actually simulates. Hit Simulate, choose DC operating point, and run it. The engine solves the whole circuit and drops real numbers straight onto the diagram. Voltage on every node, current through every branch. Break the loop, and the numbers fall to 0. No current, no light. It is the fastest way to sanity check a diagram before you ever cut a strip. So here is the whole thing, one more time. Read the reel. 2 wires, 4 or 5, and 12 or 24 volts. Size the supply to your watts, plus 20%. Cut only on the marked lines, and keep the polarity when you join. And on long runs, inject power so the far end never goes dim. Want it to stick? Open the same LED circuit free in your browser, run the simulation, and rewire it until every number makes sense. The link is in the description. No install, no credit card. New to this? Watch the LED lights and dimmer videos next. And subscribe for a new wiring diagram, explained every week. See you in the next one.